All right, so the last little bit on this topic, from this topic on series, is on loan repayments, or sometimes called time payments. And so the best way for you to learn about this topic is just from some examples. So really this topic is about calculating what the repayments are when you borrow an amount from a bank. And we're going to set up a series or a pattern, and then use what you've learned. Use some of the formulas that you've learned in this topic to apply them to real life questions. Alright, so in this first question we've got Farmer Brown, and he buys a harvester for $250,000 and pays it off over 3 years in equal yearly instalments. If the interest rate on the harvester is 14.5% per annum, find the amount of each yearly instalment. So he's making 3 yearly instalments. So we can't just do 250,000 divided by 3 and say that's how much he has to pay each year, because he has to pay back the $250,000 plus the interest. And the interest is calculated throughout the year. You can see that, it doesn't actually say interest is 14.5% per annum. It doesn't say how often interest is compounded, but I guess because he's making yearly instalments, we'll say that interest is being compounded yearly. So really what's happening is he's borrowing the $250,000, interest accrues for the whole first year, and then that interest is added on to the $250,000, and then he pays his first yearly instalment. Then after he pays that yearly instalment, the amount owing at the end of the first year then becomes the new amount owing at the beginning of the second year. That becomes now the principal for the second year. And then we add up, then interest is added on to that amount as well. It accrues the whole year. And then he makes his second yearly instalment. And then the amount owing at the end of that second year then becomes the new amount owing at the beginning of the third year. Okay, that becomes the new principal for the third year. The interest is calculated again for that whole balance that's owing and added on, and then he makes his final yearly instalment, his third yearly instalment. And after he makes that yearly instalment, then the balance owing should be zero, because then he's paid off his $250,000 plus all of his interest over those 3 yearly instalments. So it's really important to understand what's happening in these questions. So let's have a look and see how the solution for this question. So I've got the question for you smaller a little bit again over here, and then over here I'm just on the left hand side, I'm just going to show you the working out, and I just covered it up so it's not too much information overload straight away. Alright, so A1 is going to represent the amount owing at the end of the first year, and that's going to be the principal. We're going to add on the interest, so using the compound interest formula for 1 year, and then he makes his yearly instalment, which we're going to call M. We in most of the questions in this topic, it's monthly instalment, so we use M. We could have used Y in this question, but just out of habit, I just use M all the time. So the amount owing at the end of the first year is going to be that expression there. Now remember, this amount then becomes the principal at the beginning of the second year. So the amount owing at the end of the second year then becomes, there's our new principal, the amount owing at the end of the first year. We're going to add on some interest, so 1 plus R to the power of 1, and then we're going to make our second yearly instalment. Alright, let's now replace all of this with A1, because remember, all of that is A1. So substituting that in there, you can see everything I've got in the square brackets there is our A1. And we're going to multiply everything here by 1.145, which is what this bit's saying. So 1.145 times this, and 1.145 times M. So when we multiply 1.145 times the first 250,000 times 1.145, we get 250,000 times 1.145 squared. Then when we multiply this, we get this, and we've still got the minus M from the end. So that is then the amount owing at the end of the second year. The amount owing at the end of the second year then becomes the amount owing at the beginning of the third year, so the principal at the beginning of the third year. So we have our new expression here where the amount owing at the end of the third year is the amount owing at the end of the second year. We're going to add on some interest and we're going to subtract that third and final yearly instalment. All right, now we are going to replace A2 or times all of that, because that's A2, by 1.145. So we've got this first term times 1.145, which becomes 250,000 times 1.145 cubed. Then we've got 1.145m times 1.145, and you get 1.145 squared m. Then we've got m times 1.145, which is that term there, and then we've got the minus m on the end, that final payment. Alright, so now we have an expression for the amount owing at the end of the third year. But remember, the amount owing at the end of the third year, because he's going to pay it off, whoops, that's moving around, paying it off in 3 years, how much should he owe at the end of those 3 years? Did you say 0? That is absolutely right. Oh, before we get to that, we want to just factorise out the m in these last three terms, because then you can see what's in brackets here is the sum of a geometric series, especially if we just swap the order of them. It's a bit easier to see. Let's move this box down one more time. There we go. At the end of the third year, the amount owing is 0. So A3, this whole expression here, equals 0. Pretty cool. That is going to allow us to solve the equation to find what m is. Because remember, m is the amount of each yearly instalment, which is what the question is asking us to find. Okay, so making that equal to m, you can see over here on the right hand side, I've just replaced, I've just made an easier equation for you to solve, that you do know how to solve. So I'll just move this down a little bit again, the white box. Alright, now you can see that if we just say we had an equation like 5 minus 2x equals 0, we would move the 2x over, and to get x by itself we'd have to divide both sides by 2. There's a little 2 there that is cut off. Let me just write it at the top. So x equals 5 on 2. So in this funky big equation here, it's like this whole thing, this whole term here is the 5, and this whole thing is the 2, and of course m is the 2, m is the x. So we need to move this whole thing to the other side, and then we've got to do this divided by that to get our m. And you can see our denominator, like I mentioned before, is the sum of a geometric series, where the first term is 1, a is 1, the common ratio is 1.145, t2 divided by t1, t3 divided by t2, and the number of terms you can see quite easily is 3. So, substituting into the sum of a GP formula, we get that. There's our sum of a GP formula. Sorry, the little 2's moving down. Oh, that's why it was there. It was just cut off. Okay, and then you can simply put that in your calculator, or using what you know about fractions, you do one more step. So sometimes these questions just show, so it's easy, so it's good to know this extra step. When you've got a numerator divided by a fraction, it's really a numerator times the reciprocal of this. So that's why the 0.145 ends up becoming up here on the numerator. Alright, and then that still becomes part of the denominator there. So now you can just put that in your calculator. You get m, remember the m is the amount of each yearly instalment, becomes $108,587.44. And that's how much Farmer Brown needs to pay every year to pay off his harvester in 3 equal yearly instalments. Okay, let's have a look at another example. Maria applies for a loan of $15,000 to be paid back in monthly instalments over 5 years. The interest on the loan is 16%. How much does Maria owe after 1 month? So, let's have a look at this solution. And I've just made the question smaller for you again over here. So because we've got monthly instalments, it means we want to change end to months and the rate to months. So to change the rate to months, that's what we've done here. We've divided the rate by 12, and you can get that as a fraction, 1 on 75 as a fraction. And then because there's 12 months in 1 year, in 5 years there'll be 60 months. So the amount owing after 1 month is going to be her principal. Then we've got 1 plus r to the power of 1 minus m. So that's how much she owes at the end of 1 month. What is the amount of each monthly instalment then? Well, we're going to set up this series and do the same thing we did for the harvester. All right, so the amount ending at the end of the second year becomes the amount ending at the end of the second month. Amount owing at the end of the first month becomes the new principal for the beginning of the second month. And then we've got more interest for another month minus the next monthly instalment. So what we need to do is all of that is our A1 there. So we want to divide times 1 plus 1 on 75. We want to times this by this term and this term. So when we multiply this term by 1 plus 1 on 75, you can see we get the squared there. When we multiply m by this term, you can see we get that term. And then the minus m stays on the end. Then the next step that I've done is I've just factorised out m out of these two terms, and then you can start to see a pattern that's emerging. Maybe if I added in A3, it may have helped to see the pattern here, but I've jumped straight to A60 because remember it's going to be paid off in equal monthly instalments over 5 years. So that last instalment will be the 60th instalment, and the amount owing after 60 years. So with our little series here, can you see how that power there is the same as the number of months? So 60 means we got to the power of 60 here. And then in this series in here, we got 1, then we got that, and then the power here is 1 less than that power there. So that means our series are going to go all the way up to 59 because that's 1 less than 60. Okay, now line there copied out again for you here. All right, now remember though, at the end of 60 months, the amount owing is going to be 0 because they're going to have paid it off over those 60 months. So we'll make all of this equal to 0. And just like before, we need to solve for m. So this time, I've just actually substituted into the sum of the GP formula this sum of this. You can see that that's the sum of the GP, where the first term is A, the common ratio is the 1 plus 1 on 75, and the number of terms, you can see the power there is 1. So we've got from the power of 1 up to the power of 59. We've also got this term here, which means a total of 60 terms in this series. That's why I've got to the power of 60 there. And then minus 1, and then all over the common ratio, r minus 1. There's the common ratio, and when we minus 1, we're just left with 1 on 75. Okay, so to solve this equation for m, we need to move this whole term to the other side of the equal sign, and then we'll have this divided by this. So we've got this over here. When we divide by this, we times by the reciprocal, so that's why the 1 on 75 comes on the numerator, and that's on the denominator. And then you can just put this in your calculator, and you get the amount of each monthly instalment. Alright, and then the last part says, how much money will Maria pay on the loan altogether? Well, if she's paying $364.77 every month for 60 months, then you can see if you multiply those together, that's how much she is going to be paying back altogether. So $21,886.20. And then, if just say the question asked how much interest would she pay over those 5 years, well, you can see that she borrowed $15,000, and if she's paid back $21,886.20, the interest is going to be the difference between those amounts. So what has she paid? About $6,886.20 in interest. One more example. Slightly harder this time. So Furniture Galore has a special deal where you can buy a lounge on hire purchase and pay it off over 2 years. No payments are needed for the first 3 months. Sounds like a good deal. Hire purchase interest is 18% per annum. Interest is compounded monthly. If George buys a $3,000 lounge, find the amount he owes after 3 months and then the amount of each monthly repayment. Now, even though they are saying no payments are required for the first 3 months, what's happening is that interest is still accruing over those 3 months. That's why the question says for part A, how much does he owe after 3 months? He doesn't still owe $3,000. He owes the $3,000 plus the amount of interest for those first 3 months. Okay, so let's have a look on. Alright, so we've got 18% per annum, but remember he is making monthly repayments. So we have to change the rate to a monthly rate, which is what I've done here. Also, he's paying it off over 2 years. Oops, I accidentally crossed it out, and that's 24 months. Now, the first question is how much does he owe after 3 months? So we're going to call this A3, the amount owing at the end of 3 months. Oops. And that's going to be the principal, $3,000, plus the interest, so 1 plus R to the power of 3. So that's for 3 months. So you can see at the end of 3 months he owes $3,137.04. All right. Then this amount that he owes at the end of the 3 months becomes the new principal for the amount owing at the end of 4 months. So the amount owing at the end of 4 months, we've got our new principal, which is the amount owing at the end of the 3 months. We're going to add on some interest. Remember, when I say add on interest, it's like times by 1 plus R. Okay, we're doing a percentage increase. And then we minus M, the monthly repayment. So that is the amount owing at the end of the 4th month. And now we are going to replace the A3 with what we found earlier. So there's A3, remember, oops, not the 3173, just that bit there is A3. So we're going to multiply that by 1.015. So that becomes 1.015 to the power of 4. Oh, I've missed out a little 1 in there. And then we have the minus M. All right. Oh, maybe I've done that the whole way. No, just in a couple of the lines. So there we have the amount owing at the end of the 4th month. This then becomes the new principal to calculate the amount owing at the end of 5 months. So the amount owing at the end of 5 months is A4 times, well, adding on some interest, times 1.015 minus the monthly repayment. So we need to multiply 1.015 by both this term here, oops, and the M. So when we multiply it by that first term, we get 1.015 to the power of 5. When we multiply it by the M, we just get, oops, moving around, that term there, and then that minus M is the same. All right. Let's move some of these rectangles out of the way. Oops. Okay, there we go. Next step, you can see I've just factorised out M out of these two terms. All right, that's amount owing at the end of the 5th month. Let's set up one more, A6, before we go to the final A24. Amount owing at the end of 6 months then is the new principal, A5. Amount owing at the end of 5 months becomes the principal for the next month. Add on some interest, minus M. You can see what's happening here. Multiply everything in A5, oops, by 1.015. And you can see that's what we're doing there. The first term then becomes 3,000 times 1.015 squared by multiplying that times that. And the next term becomes 1.015 squared. Oh, sorry, did I say squared for that one? I meant to the power of 6. And then 1.015m, and then the last minus m is the same at the end there. And then you can see the next step I've just done is to factorise out m out of these last 3 terms. And you can see that there is a pattern emerging. Let's see if we can write an expression for the amount owing at the end of 24 months. So the amount owing at the end of 24 months. So you can see I've got a little ... So can you notice that the month there is equal to the power there? Same there, 5 there, 5 there. So A24, there'll be a 24 there. Then we have a sum of a GP here, 1 plus 1.015 plus 1.015 squared. The highest power there is how many less than the number of months? It is 4 less. Because remember, there was 3 months where he wasn't paying anything. And then the first one would have just been the M. And you can see here the power there is 1 and 5 minus 1 is 4. So there's always 4 difference between that last power there. So if there's 4 difference, you can see that our last power is going to be to the power of 20. So this is what I mean about using patterns rather than writing out all of the amount of rings between A6 to A24. Then you can see in the brackets here we have a sum of a geometric series. The first term is 1. The common ratio is 1.015. And let's see if we can use the powers to work out the number of terms in this series. Well, imagine there's a little power of 1 just there. We've got from the power of 1 to all the way up to 20. So there's 20 terms there, plus we've got this term at the front. So there's 21 terms in that whole series. So that's why I've got here to the power of 21. Alright, so this is just using the, sum of a GP formula there. And then remember, the amount owing at the end of 24 months is 0, because then he will have paid off his special hire purchase loan to buy that lounge. So we just need to solve that equation to find M. So we can move, we can move this little M. Let me move that box, there we go. Move the M, this whole M term, over the other side of the equation, then we'll have this divided by this, which means this times this divided by that, which is what we've got. And we're just going to, maybe have I cut that off? Let me see if I can move it up. There is the final answer. So just putting that in your calculator. 175.25 is the amount of each monthly repayment. That's it. So I hope you've learned a few life skills in this. When people advertise 3 months no payments, they don't really mean you're having a good deal, because that interest is still accruing.